Recently, our client Tommy met his banker to discuss continuing his father's restaurant legacy. In us, he found a partner that understood the importance of passing the torch. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Tommy. Tonight in Arkansas, there's a mother tucking in her daughter and turning off the light. A business owner is burning the midnight oil. An at-home dinner date is plating up possibility. And it's all happening under one roof. How? The power of a conversation, like the one John from Integrity Solutions had with First Horizon Bank about his vision for a sustainable mixed-use building. Now it's not just words, it's life. First Horizon Bank. Let's find a way. Go to firsthorizon.com/John. First Horizon Bank, member FDIC.
Hi there, thanks again for joining me on Astronomy Daily. Andrew Dunkley here, your host. Coming up today, a mystery of our galaxy has been solved. Yet another huge telescope to be built and a new tool to unravel the mysteries of the sun. Hope you can stick around for this edition of Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.
Time to say hi to our AI reporter, that is, Hallie. G'day, Hallie.
G'day, Andrew. That's so hard to say.
Yeah, it is. People from overseas often struggle with saying g'day. It's something you've got to be born into, I think, and it is unique to Australia. It's just our abbreviation for good day or good morning or hello, but it's just become part of our standard vernacular, g'day. It's soft on the G, so you just hit it soft. G'day, g'day. Try it again.
G'day.
You got the accent right, but the inflection's all off. Keep working on it, Hallie. What's happening in the news?
NASA's Ingenuity Mars helicopter flew for the 37th time last week, acing a hop designed in part to test the capabilities of its new software. Ingenuity stayed aloft for 55 seconds and covered 203 feet, 62 meters, of red planet ground on the flight, which was its third this month. The main goals of Saturday's sortie were for Ingenuity to reposition itself and test new flight software capabilities, according to officials with NASA's Jet Propulsion Laboratory, JPL, in Southern California. That new software, which was installed last month, allows Ingenuity to avoid hazards during landing and to use digital elevation maps for navigation purposes. Ingenuity has now traveled a total of 24,867 feet, 7,479 meters, and stayed airborne for nearly 62 minutes during its 37 red planet flights, according to the mission's flight log. Those numbers should continue to increase for a while, for the chopper remains in good health. Still on Mars, and NASA's InSight lander sent back what might be the rover's final image. InSight is expected to lose contact with Earth any day now, as Martian dust builds up on the solar panels that power the 19-foot-long Planet Explorer. NASA reported that InSight did not respond to communications from Earth on December 18 and that the last time the mission was able to contact the spacecraft was on December 15. The lander may have officially reached its end of operations. Short for interior exploration using seismic investigations, geodesy and heat transport, InSight launched in May 2018 on a mission to be the first robotic lander to look deep into the interior of the red planet, to study its crust, mantle, and core. NASA delayed a planned spacewalk to venture outside the International Space Station at the last moment on Wednesday, after a large piece of Russian space debris came dangerously close to the orbital outpost. NASA astronauts Frank Rubio and Josh Cassada were getting ready to step out from the US-built Quest airlock on the International Space Station to install new solar arrays when their mission control team commanded them to halt the work. Instead, the space station performed an emergency maneuver to get out of the way of a large piece of space debris that was on track to get dangerously close to the lab. The debris in question is a piece of a Russian rocket, the 11-foot-wide, 3.35 meters, Fregat upper stage used on Soyuz and Zenith launchers. The junk was predicted to get within less than a quarter of a mile, 0.4 kilometers, from the station. And that's the news, Andrew.
Thanks, Hallie. And one suspects that these kinds of issues are just going to happen more and more as more and more satellites and rockets are launched from the Earth's surface. We'll talk to you before the end of the show. Now, to other news, astronomers say they have solved an outstanding problem that challenged our understanding of how the universe evolved: the spatial distribution of faint satellite galaxies orbiting the Milky Way. Now, these satellite galaxies are in a bizarre alignment. They seem to lie on an enormous thin rotating plane called the plane of satellites. Now, this is a rather unlikely scenario, and it's puzzled astronomers for over 50 years, and it's led many to question the validity of the standard cosmological model that seeks to explain how the universe came to look the way it does today. Well, now, new research, jointly led by the universities of Durham in the UK and Helsinki in Finland, has found that the plane of satellites is a cosmological quirk, which will dissolve over time in the same way that star constellations also change. Professor Carlos Frenk, Ogden Professor of Fundamental Physics in the Institute of Computational Cosmology at Durham University in the UK, was part of the team that made the discovery, and a former colleague of Professor Fred Watson, who explains the findings.
Carlos and his colleagues have essentially discovered that the disk-like formation of these satellites, and I should add that you see this in other galaxies as well, not just in our own. It's something that sort of happens almost automatically when you run your simulations very accurately, and it's something to do with the distances of these satellites from the center of the galaxy, and I guess what they were perhaps doing is putting them all at the same distance, which would make your satellites look like a sphere of stuff around. Whereas if you put them at their differing distances, then the interactions between them, the gravitational interactions between them and with the galaxy, tends to pull them into a disk. So it's a kind of natural consequence of this arrangement of satellites that has been seen as a mystery before, as the phys.org article says, describing this. There's no known physical mechanism that would make satellites planes. And so they should be in a round configuration, but it's by putting in this additional ingredient into the mix when you do the analysis of the simulations of this. And I have to say, Carlos is one of the great leaders in the world in doing cosmological simulations. They've got essentially a model universe in their computers in the University of Durham there. So they can test all these things. But yeah, it turns out that it's effectively a chance alignment which comes and goes. And in fact, Carlos, there's a nice quote from Carlos here. He said, "The strange alignment of the Milky Way satellite galaxies in the sky had perplexed astronomers for decades, so much so that it was deemed to pose a profound challenge to cosmological orthodoxy." In other words, have we got it all wrong?
Yeah.
But thanks to the amazing data from the Gaia satellite, so that's another thing that's gone into the mix here, and the laws of physics, we now know that the plane is just a chance alignment, a matter of being in the right place at the right time, just as the constellations of stars in the sky are. Come back in 1 billion years, and that plane will have disintegrated, as will today's constellations. We have been able to remove one of the main outstanding challenges to the cold dark matter theory of the universe. It continues to provide a remarkably faithful description of the evolution of our universe. Yeah, it's very nice stuff.
So what he's basically saying is what we're seeing is unusual, but also normal, and it will sort itself out.
Yes, that's right. And it happens kind of everywhere.
Yeah.
It's one of the things that maybe you could think of as a natural consequence of the evolution of galaxies. When you put them into the context of the galaxies that surround them, you know, when you study galaxies, you've really got to think of them in their environment rather than individually, because that definitely affects the way the gas motions behave within the galaxies and star formation takes place.
Professor Fred Watson, astronomer at large, and you can hear the full story on the latest edition of Space Nuts, out soon, if not already.
The Astronomy Daily Podcast
with Andrew Dunkley.
A lifetime of hard work, children laughing in the kitchen, family photos on a restaurant wall. a legacy that lives on. It all comes from the power of a conversation, like the one Tommy Hall had with First Horizon Bank about taking over his father's Charleston-based restaurant business. Now the table is set for a whole new generation. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Tommy. First Horizon Bank, member FDIC.
Now, there's no denying what humanity achieved when we sent the billion-dollar James Webb Space Telescope into space. But why stop there? Another huge telescope is currently in the works, only this one will be the largest telescope in the world. It's been dubbed the Eye on the Universe. It's a $2.66 billion piece of kit and will be a 30-metre telescope dubbed, not surprisingly, the TMT, and it will be situated in Hawaii. Now, what makes it extra exciting is that along with the US, Japan, Canada and China, India will be involved in the project in a very big way. The TMT's Indian collaborators include the Inter-University Centre for Astronomy and Astrophysics, PRUNE, the Institute of Astrophysics, Bengaluru and the Aryabhata Research Institute of Observational Sciences National, which is a fabulous collaboration. Further, over 50 Indian industries will contribute to the venture through different components and the direct or indirect involvement of approximately 200 scientists, engineers, experts and technicians, among many others. The TMT will enable the scientists to peek from 1 light year in our solar system to the early universe, around 13.7 billion light years away. If you consider that the nearest neighbour of our Milky Way galaxy, the Andromeda galaxy, is 25.3 light years away, you can see the power that this telescope's going to have. TMT's primary mirror will comprise of 492 hexagonal mirrors that will be supported by another 1,476 actuators, 2,772 high-precision edge sensors, and 10,332 smaller actuators that will align all the mirrors, detect the micro deviations, the minutest deviations, and correct them to enable clear images from staggering distances in the universe. Astronomers hope the TMT would allow them to get a better look at planets, stars, galaxies, exoplanets, nebulas, supernovas and pulsars, and conduct spectroscopy of such heavy objects to study their atmosphere. They even hope to scout for Earth-like planets and find out whether life exists or can thrive elsewhere. And the TMT is most likely set to be operating sometime after 2032. It's a long-range project, but very exciting indeed. And of course, by then, James Webb will be halfway through its designated life. And finally, to another telescope, with the world's largest solar telescope now conducting formal observations, scientists are eager to watch the sun's increasing activity and better understand the threats of space weather. Yes, the sun is waking up. The Daniel K. Inouye Solar Telescope, or DKIST, located in Hawaii, began science observations earlier this year, joining a host of other sun watchers, most notably NASA's Parker Solar Probe and the European Space Agency's Solar Orbiter. And it's perfect timing on two fronts. The sun's activity is ramping up, and sky watchers are going to see some pretty incredible eclipses in 2023 and 2024. DKIST, which is on the island of Maui, is owned by the US National Science Foundation. The observatory was designed to focus on the upper parts of the solar atmosphere, or the corona, to specialise in observing the sun's magnetic field. Now, according to Carrie Black, Program Director for the National Solar Observatory, the telescope really excels at very small-scale features that are incredibly important. Now we'll really be able to compare theory with reality on the surface of the sun, which is tremendously exciting and really going to propel the science forward. Fortunately, the solar system is giving scientists two particularly intriguing opportunities in the coming years. Sky watchers, as I said, are getting ready for two upcoming solar eclipses, an annular eclipse in October next year, will pass over the western United States, and a total solar eclipse in April 2024, which will begin in New Mexico and then be visible from the southern United States to the northeast. So they should be able to learn a heck of a lot with this new telescope. Now, if you want to chase up those stories, you know where to go, astronomydaily.io. Don't forget to sign up for the newsletter so you can get your daily dose of astronomy and space science news via email. And listen out for the latest edition of Space Nuts out now at spacenuts.io or via your favourite podcasting distributor. Anything before we go today, Hallie?
Yeah, mate, it's International Mathematics Day.
Oh, not my favourite topic. I really struggled with mathematics at school and I just never got better. So tell us about today.
The day is centered around one man. In fact, the reason Mathematics Day is set on December 22nd is because it is the birthday of India's most respected mathematician, Srinivasa Ramanujan, a math genius of the highest degree. Ramanujan was born in 1887 and spent his life under British rule in India. In spite of the fact that he had almost no training in mathematics, Ramanujan made some important contributions to the discipline, including number theory, infinite series, mathematical analysis, and continued fractions.
Wow. Oh, there's hope for me yet then, Hallie?
I doubt that, Andrew.
Haha, very funny. Bye, Hallie.
Bye.
And that's it from us. Until next time, this is Andrew Dunkley for Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.